Good morning, students. So today we have lecture number 9. Lecture number 9 on electromagnetic induction. Electromagnetic induction. So in the previous lecture also we have solved numericals. So today also we will solve some numericals, and then we shall discuss about the previous year exam question papers on this chapter. So what are the different questions appeared in the previous year exam, that we will see after solving few numericals. Okay. So next problem, write down the next problem. Write down the next problem. So, an average induced EMF of an average induced EMF of 0.20 volt. An average induced EMF of 0.20 volt appears in a coil. An average induced EMF of 0.20 volt appears in a coil when the current in it. An average induced EMF of 0.20 volt appears in a coil when the current in it is changed from. When the current in it is changed from. When the current in it is changed from 5.0 ampere in one direction, 5.0 ampere in one direction to 5.0 ampere in the opposite direction, 5.0 ampere in opposite direction. Okay. An average induced EMF of 0.20 volt appears in a coil when the current in it is changed from. When the current in it is changed from 5.0 ampere in one direction to 5.0 ampere in the opposite direction in 0.20 second. In 0.20 second. In 0.20 second. Find the self-inductance of the coil. 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 Understand the question properly? Understand the question properly. See here, the induced EMF is given and current is changing from 5.0 ampere in one direction to 5.0 ampere in opposite direction. So first current is in this direction, then current becomes in opposite direction. So in a time interval dt is equal to 0.20 second, then find the self-inductance. Solution. So we know that the induced EMF is given by E is equal to minus L d phi by dt. Minus L d phi by dt. Okay. So it is minus L di by dt. Okay. We know that the average induced EMF, that is the induced EMF is given by E is equal to minus L di by dt. Minus L di by dt. Actually it is E is equal to d phi by dt. E is equal to d phi by dt and phi is equal to L into I. Phi is equal to L into I. So L is taken common. So we will get di by dt. So now di by dt, that is L is equal to, therefore L is equal to E divided by di by dt. So E, that is induced EMF. So induced EMF is 0.20 volt and di, that is change in current. First current is 5.0 ampere in one direction, then current 5.0 in opposite direction. That is 5.0 in one direction minus 5.0 in opposite direction. That's why you write it as negative, because the direction is changing. Write one as negative. Either you write this one as negative or this one as negative. So, okay, if you take this negative, I will write this as negative. Okay, write this as negative. So, divided by dt. dt is time taken is 0.20 second. So, therefore, so simplify this one. So, E is equal to minus minus. So, this is minus minus will cancel. So, di by dt. So, that is di by dt will come so to be, so minus 5.0 minus 5.0, so minus 10 divided by, this is 0.2 is nothing but 1 by 5, so minus 50, so 0.20 divided by 50. So the answer will come so to be, I will tell the answer. So you calculate the things. So it will come, so it will be 4.0, no, not E, this is L. L is equal to 4.0 milli Henry, 4.0 milli Henry. So this is the answer. So do the calculation, we'll get the answer. Understood? So here what they have given is the direction of the current, first in one direction, then in opposite direction. So therefore, while writing di by dt, di, that is change in current, first it is in one direction, then in opposite direction. So one of them has to be taken as negative. One of them has to be taken as a negative. Okay. So minus 5.0 and minus, this is positive, plus into minus, minus. Understood? Okay. So next question. Write down the next question. Next question is homework. Next question is homework. You only do it simple. Calculate the energy stored in an inductor. Calculate the energy stored in an inductor of inductance. Calculate the energy stored in an inductor of inductance 50 millihenry. Calculate the energy stored in an inductor of inductance 50 millihenry. Calculate the energy stored in an inductor of inductance 50 millihenry when a current of 2.0 ampere is passed through it. When a current of 2.0 ampere is passed through it. Very simple question. You only do it, just one line answer. When a current of 2.0 ampere is passed through it. Calculate the energy stored in an inductor of inductance 50 millihenry when a current of 2.0 ampere is passed through it. Answer for this one, I will give the answer. Answer for this one is 0.10 joule. The answer for this one is 0.10 joule. The energy stored is 0.10 joule. Understood? Solve. This is homework. Simple question. Homework. Okay. Next question. Write down the next question. Next question. A conducting circular loop. A conducting circular loop. A conducting circular loop is placed in a uniform magnetic field. A conducting circular loop is placed in a uniform magnetic field. A conducting circular loop is placed in a uniform magnetic field. B is equal to, capital B is equal to 0.020 Tesla. Capital B is equal to 0.020 Tesla. He has given a conducting circular loop is placed in a uniform magnetic field. Capital B is equal to 0.020 Tesla. With its plane perpendicular to the field. With its plane perpendicular to the field. You please stop. Once again I will tell. A conducting circular loop is placed in a uniform magnetic field. A conducting circular loop is placed in a uniform magnetic field. Uniform means constant. Uniform magnetic field. B is equal to 0.020 Tesla. With its plane perpendicular to the field. With its plane perpendicular to the field. Give please stop. Somehow, the radius of the loop starts shrinking. The radius of the loop starts shrinking. The radius of the loop starts shrinking. Shrinking at a constant rate of 1.0 millimeter per second. 1.0 millimeter per second. Somehow, the radius of the loop starts shrinking. Somehow, the radius of the loop starts shrinking at a constant rate of 1.0 millimeter per second. You please stop. Somehow, the radius of the loop starts shrinking at a constant rate of 1.0 millimeter per second. You please stop. Find the induced EMF in the loop. Find the induced EMF in the loop. Find the induced EMF in the loop. At an instant when the radius is at an instant when the radius is 2 centimeter. At an instant when the radius is 2 centimeter. At an instant when the radius is 2 centimeter. So this is the question. Read the question properly and pause the video and try to solve if it is possible. Okay. So see the question. So looks like very difficult. It is not difficult. Just we have to think as per the given question. Here, what he has given? A conducting circular loop is placed in a uniform magnetic field. A circular loop is there in a uniform magnetic field. Magnetic field is uniform and conducting circular loop is and it is placed with its plane perpendicular to the field. That is, the plane of the circular loop is perpendicular to the magnetic field. And somehow the radius of the loop starts shrinking at a constant rate. That is, radius of the loop starts shrinking. That means the area of the circular loop is changing. The area of the circular loop is changing. At a that is, the radius is shrinking at a rate of 1.0 millimeter per second. So this is nothing but rate of change of radius. Rate of change of radius, that is dr by dt. So dr by dt is equal to 1.0 millimeter per second. 1.0 millimeter per second, and you have to find the induced EMF in that circular loop at a instant when the radius is 2 centimeter. At an instant when the radius is 2 centimeter. Understood the question? So now let R be the radius of loop at a time t second. At a time t second. Let R be the radius of the loop at time t second. Then the magnetic flux linked with the loop. Then magnetic flux linked with circular coil. Is given by that is phi is equal to BA. Phi is equal to BA. That is magnetic field into area. Magnetic field into area, and the plane of the coil is perpendicular to the magnetic field. Plane of the coil is perpendicular to the magnetic field. That means theta is equal to 0 degree. So therefore phi is equal to BA, and A, that is area. So you can write B into pi r square. B into pi r square. So therefore now the induced EMF is given by E is equal to d phi by dt. E is equal to d phi by dt. So therefore E is equal to d by dt of phi. Phi is B pi r square, and B is uniform because they have given that magnetic field is uniform. That means magnetic field is constant, you cannot differentiate that. So magnetic field is taken outside, and pi is also constant, taken it outside. So differentiation of r square with respect to dt. So that will becomes 2r dr by dt. 2r dr by dt. Understood? Differentiation of r square with respect to dt. So that is 2r dr by dt. So now substitute the values. You will get the answer. So E is equal to B, that is magnetic field is 0.020 Tesla into pi, that is 3.142 into 2 R when the radius. So that is EMF when the radius is radius they have given radius is that is 2 centimeter, and the radius is 2 centimeter. So that is R is equal to 2 centimeter. That means you have to substitute here R as 2 centimeter. That is 2 into 10 to the power minus 2, and dr by dt, that is rate of change of radius. Rate of change of radius is 1 millimeter. That is 10 to the power minus 3 meter per second. So now simplify this and you will get the answer in volt. So simplify that, you will get the answer. So the answer will come so to be. So I will write the answer directly. 2.5 into 10 to the power minus 6 volt. 2.5 into 10 to the power minus 6 volt. That is 2.5 microvolt. 2.5 microvolt. This is the answer. Understand the question. See here, simple. The area of the loop, the area of the circular loop is shrinking. That is, radius is shrinking. That is dr by dt at the rate of 1.0 millimeter per second. That is the rate of change of radius. Rate of change of radius. So now apply the known things and this much of mathematics you know, differentiation you know. So do the differentiation, then you will get the answer. Understood? Okay. Write on the next question. Write on the next question. Magad Express. Next question, write down. Next question. Magad Express takes Magad Express. That is train of name of the train. Magad Express takes 16 hours to cover. Magad Express takes 16 hours to cover. That is time taken is 16 hours to cover the distance of 960 kilometer, to cover the distance of 960 kilometer. Magad Express takes 16 hours to cover the distance of 960 kilometer between Patna and Ghaziabad. Magad Express takes 16 hours to cover the distance of 960 kilometer between Patna and Ghaziabad. You please stop. The rails are separated by the rails are separated by 130 centimeter. The rails are separated by 130 centimeter. The rails are separated by 130 centimeter, and the vertical component of the Earth's magnetic field is and the vertical component of the earth magnetic field is 4.0 into 10 to the power minus 5 Tesla. And the vertical component of the earth's magnetic field is 4.0 into 10 to the power minus 5 Tesla. You please stop. It is BV. BV is equal to how much? 4.0 into 10 to the power minus 5 Tesla. Next line, right? A, first one. A anta bariri. Find the average EMF induced across the width of the train. Find the average EMF induced across the width of the train. Find the average EMF induced across the width of the train. You please stop. Find the average EMF induced across the width of the train. You please stop. B. Next line. B. If the leakage resistance between the rails is 100 ohm. If the leakage resistance between the rails is 100 ohm, find the retarding force. Find the retarding force on the train due to the magnetic field. Find the retarding force on the train due to the magnetic field. Find the retarding force on the train due to the magnetic field. Okay, see here. So what they have given? So Magad Express takes 16 hours to cover the distance of 960 km between Patna and Ghaziabad. So distance is 960 km and the time taken is 16 hours. So therefore we can find the velocity of the train. So the velocity of the train and it moves in the Earth's magnetic field. So it is moving on the Earth means it is moving in the Earth magnetic field. So that the magnetic field, the component of the vertical component of the magnetic field is 4.0 into 10 to the power minus 5 Tesla. Then find the EMF induced across the width of the train, and also they are asking what is the retarding force acting on the train. What is the retarding force acting on the train? Okay, so now let us find first to find the velocity of the train. The velocity of the train is the velocity of train. Velocity of train, that is v is equal to ds by dt, that is distance travelled divided by time taken. Distance travelled is 960 kilometer, and time taken is 16 hours. So simplify this one, you will get the answer as v is kilometer per hour, that is in kilometer per hour. So you will get v is equal to in meter per second as 16.67 meter per second. So you simplify that one to the meter per second by multiplying 5 by 18. You multiply it by 5 by 18, you will get in meter per second. So that is 16.67 meter per second. That is the velocity of the train. And the train moves in the magnetic field of the earth, and the magnetic field which is perpendicular to the plane of motion of the train. The magnetic field perpendicular to the plane of motion of the train is vertical component of magnetic field. The magnetic field which is perpendicular to the plane of motion of the train is vertical component of the magnetic field. So therefore we have to take vertical component of the magnetic field only, and he has given that one only. If he has given a total magnetic field, then we have to find the vertical component of the magnetic field by using angle of dip. By using angle of dip, if he has given a total magnetic field B of the earth, then we have to find BV. BV is equal to B into sine delta. Delta is angle of dip. So that's all the things we have studied in the previous chapters only. So that is the vertical component of the magnetic field. Due to the vertical component of the magnetic field only, the induced EMF is produced in the train. So therefore the EMF produced, that is the train is nothing but a conductor moving in a magnetic field. So that is nothing but motional EMF. That is the EMF induced in the width across the width of the train due to the motion of the train is given by E is equal to BLV. E is equal to BLV, and B is the magnetic field perpendicular to the plane of motion of the train, and magnetic field B is magnetic field perpendicular to the plane of motion of train, and it is BV, that is vertical component of Earth's magnetic field. So therefore E is equal to BV into LV. So therefore BV, that is a vertical component of the Earth magnetic field, they have given. It is 4.0 into 10 to the power minus 5 into L. L length of the width of the train, not length of the train, width of the train. So width they have given. So 130 centimeter. Width of the train is 130 centimeter. That is 130 into 10 to the power minus 2 into V. Velocity of the train 16.67 meter per second. So now we will solve this one and you will get the answer. The answer will come so to be, so 8.6 into 10 to the power minus 4 volt. 8.6 into 10 to the power minus 4 volt. Understood? So this is the induced EMF across the width of the train. So now, and B, in the B what they are asking, if the leakage resistance between the rails is 100 ohm, find the retarding force on the train. That is, resistance is given. So the leakage resistance is given, the leakage current. So that is the current, the leakage current, we say it as leakage current. So I is equal to E divided by R. So I is equal to E is 8.6 into 10 to the power minus 4 divided by resistance is 100. So it is traveling. So this is the current flowing through the width of the train. So then the force experienced by that conductor is F is equal to BIL. F is equal to BIL. So once again substitute the value B. That is B is vertical component of magnetic field only. So 4.0 into 10 to the power minus 5 into I is 8.6 into 10 to the power minus 4 divided by 100 into L. L is 130. 130 into 10 to the power minus 2. And now simplify this one, we'll get the force acting on the train, that is retarding force acting on the train, the retarding force. And this force is that is Lorentz force. This force is in a direction opposite to the direction of motion of the conductor. We have told in the theory class about all these things. So that is energy consideration in EMF anta heli nodri. So during that we have told that the force acting is in a direction opposite to the direction of motion of the conductor. So therefore this will be a retarding force acting on the train, and the value comes out to be, and do the simplification, you will get the value as, I'll give the value directly, the value comes out to be 4.47 into 10 to the power minus 10 Newton. 4.47 into 10 to the power minus 10 Newton. Okay. Understand this question properly, and such kind of questions asked many times in the CET exam, Karnataka CET exam and NEET exam. You open the previous year question papers, so you will see this question paper related to motion of the train in a magnetic field, and EMF is induced in the train, so that is width of the train. So many times they have asked, that's why I solved this numerical. Understood? Okay. So next numerical, write on the next numerical. This is next numerical is homework like this only. So like this only, little bit different is there. So you can solve it. You can solve it. I'll give the hint. Same type of numerical. Write down. A jet plane is traveling towards west. A jet plane is traveling towards west. A jet plane is traveling towards west. At a speed of, a jet plane is traveling towards west at a speed of 1800 km per hour. A jet plane is traveling towards west at a speed of 1800 km per hour. What is the voltage difference developed between the ends of the wing? What is the voltage difference developed between the ends of the wing? What is the voltage difference developed between the ends, ENDS, ends of the wing? Ends of the wing. Having a span of 25 meter. Having a span of 25 meter. Give comma. Having a span of 25 meter, comma. If the Earth's magnetic field at the location, has a magnitude of, if the Earth's magnetic field at the location has a magnitude of, if the Earth's magnetic field at the location has a magnitude of 5 into 10 to the power minus 4 Tesla. 5 into 10 to the power minus 4 Tesla. If the Earth's magnetic field at the location has a magnitude of 5 into 10 to the power minus 4 Tesla, and the dip angle is 30 degree, and the dip angle is 30 degree, and the dip angle is 30 degree. You please stop. Okay, this is the question, and this question is same. Instead of train, they are using a plane. A plane is moving in the magnetic field of the Earth, Earth's magnetic field, and the length of the wings of the plane is 25 meter, and train is moving with a speed of 1800 km per hour. Then the EMF is induced. EMF is induced across the width of the plane. So then the EMF induced is given by E is equal to BLV, and B is the magnetic field. Magnetic field perpendicular to the plane of motion of the plane. Perpendicular to the plane of motion of the aeroplane. Magnetic field perpendicular to the plane of motion of aeroplane, and that magnetic field will be once again BV only. That is BV. That is vertical component of Earth's magnetic field. Vertical component of Earth's magnetic field. And here he has not given BV. Here they have given the total magnetic field of the earth. So therefore, hint, I will give the hint. So it is BV is equal to B into sin delta. BV is equal to B into sin delta. Delta is angle of dip. Angle of dip is as given as 30 degree. So this BV you have to, thus using the value of BV is equal to B sin delta. Using the value of BV, you can find the into the EMF, that is motional EMF across the wings of the aeroplane. Understood? Okay, try to solve that numerical as homework. And now let us understand or let us see the questions asked in the previous chapter. So EMI on this electromagnetic induction, what are the questions asked in the previous exams? That is March 2014. March 2014, what are the questions asked in the previous exams? So I will read the questions, you just go through. Okay. So first 1 mark question, they have asked, give the expression for energy stored in the inductance coil carrying current. Give the expression for energy stored in the inductance coil carrying current, only for 1 marks. And next 2 marks question they have asked. 2 marks question they have asked, mention any 2 advantages of eddy currents in the practical applications. Mention any 2 advantages of eddy currents in the practical applications. This is for 2 marks. And next 1 more question is there for 3 marks. And the question is, state and explain Lenz's law for induced EMF. State and explain Lenz's law for induced EMF. You have to explain Lenz's law, not Faraday's law. If you write Faraday's law, you won't get the marks. Only you have to write state Lenz's law, then you have to write the explanation of Lenz's law. Understood? Don't write Faraday's law, not required. State and explain Lenz's law for induced EMF. They are asking, and for 3 marks they are asking. If you write statement, you will get 1 mark, and if you explain it, you will get 2 marks. Understood? Okay, this is for March 2014. And next March, July 2014. July 2014. July 2014. 1 mark question. State Faraday's law of electromagnetic induction. State Faraday's law of electromagnetic induction. 2 marks question. What are eddy currents? What are eddy currents? Question mark. Give one use of it. What are eddy currents? Question mark. Give one use of it. Next 3 marks question. One more 3 marks question. Derive an expression for electromotive force induced in a rod moving perpendicular to the uniform magnetic field. Derive an expression for electromotive force induced in a rod moving perpendicular to the uniform magnetic field. So these all are the questions asked in July 2014. And next March 2015. March 2015. So 1 more question. Mention the significance of Lenz's law. Mention the significance of Lenz's law. 2 mark question. 2 mark question. 2 mark. Numerical they have asked. Numerical they have asked. Write on that numerical. Current in a coil falls from. Current in a coil falls from 2.5 ampere to 2.5 ampere to 0.0 ampere in 0.1 second. Current in a coil falls from 2.5 ampere to 0.0 ampere in 0.1 second, inducing an EMF of 200 volt. Inducing an EMF of 200 volt. Calculate the value of self-inductance. So L is equal to question mark. We have to calculate self-inductance, and this question is asked in 2015 for 2 marks. Understood? Once again I will read. Current in a coil falls from 2.5 ampere to 0.0 ampere in 0.1 second, inducing an EMF of 200 volt. Calculate the value of self-inductance. Next 3 marks question. Derive the expression for motional EMF induced in a conductor moving in a uniform magnetic field. Derive the expression for motional EMF induced in a conductor moving in a uniform magnetic field. This is for 3 marks. And next question paper. Next question paper is July 2015. July 2015. What is self-induction? What is self-induction? For 1 mark. Next 2 marks. What are eddy currents? Give one use of eddy currents for 2 marks. 3 marks. Derive the expression for energy stored in a current carrying coil. Derive the expression for energy stored in a current carrying coil for 3 marks. This is July 2015. Next, March 2016. March 2016. March 2016. One more question. State Faraday's law of electromagnetic induction for only 1 mark. And 2 marks question. The current in a coil of self-inductance 5 millihenry. The current in a coil of self-inductance 5 millihenry changes from 2.5 ampere to 2.5 ampere to 2 ampere. 2.5 ampere to 2.0 ampere in 0.01 second. In 0.01 second. You please stop. Calculate the value of self-induced EMF. Calculate the value of self-induced EMF. This is for 2 marks. Once again I will read the question. The current in a coil of self-inductance 5 millihenry changes from 2.5 ampere to 2.0 ampere in 0.01 second. Calculate the value of self-induced EMF for 2 marks in 2016. Next 3 marks question. Explain briefly the coil and magnet experiment to demonstrate electromagnetic induction. Explain briefly the coil and magnet experiment to demonstrate electromagnetic induction. Understood? Next question paper. July 2016. One more question. What is the significance of Lenz's law? What is the significance of Lenz's law? 2 marks question. What is meant by self-inductance and mutual inductance? What is meant by self-inductance and mutual inductance for 2 marks. Next 3 marks question. Derive an expression for motional EMF induced in a conductor moving in a uniform magnetic field. Next question paper. Next question paper. March 2017. What is the significance of Lenz's law for 1 mark? What is the significance of Lenz's law? Next 2 marks. State and explain Faraday's law of electromagnetic induction. State and explain Faraday's law of electromagnetic induction. 2 marks. 3 marks question. Derive the expression for motional EMF induced in a conductor moving in a uniform magnetic field for 3 marks. Next question paper. 2017. July 2017. What is motional electromotive force? 1 mark. What is motional electromotive force? What is motional electromotive force for 1 mark. And 2 mark question. The magnetic flux linked with a coil. 2017. The magnetic flux linked with a coil varies as. The magnetic flux linked with a coil varies as phi is equal to 3t square plus 4t plus 9. Find the magnitude of the EMF induced at t is equal to 2 seconds. Find the magnitude of the EMF induced at t is equal to 2 seconds. For 2 marks. This question is for 2 marks. Once again I will read. The magnetic flux linked with a coil varies as phi is equal to 3t square plus 4t plus 9. Find the magnitude of the EMF induced at t is equal to 2 seconds. Understood? For 2 marks. 3 marks question. Mention any 3 applications of eddy currents. Mention any 3 applications of eddy currents. Understood? Okay, this is 2017. And next 2018. It is March 2018. March 2018. 1 more question. State Faraday's law of electromagnetic induction. State Faraday's law of electromagnetic induction. 2 more question. 2 more question. There is no 2 mark question. 2 marks question nahi hai. 3 marks question. 3 marks question is also not there. So 2 marks question bhi nahi hai. 3 marks question bhi nahi hai. Then there must be a 5 marks question. Then there must be a 5 marks question. Yes, a 5 marks numerical is there. And this numerical we have already solved in the class. In the previous classes we have solved. Just I will read the question. A circular coil of radius 10 centimeter and 25 turns is rotated about its vertical diameter with an angular speed of 40 radian per second in a uniform horizontal magnetic field of magnitude 5 into 10 to the power minus 2 Tesla. Calculate the EMF induced in the coil. Also find the current in the coil if the resistance of the coil is 15 ohm. We have already solved this question. If this question has a problem, there was a mistake in this question and I have told about that mistake also. So we have solved this question. Okay. Next question paper is April 2019. April 2019, 1 mark question. How the self-inductance of a coil depends on the number of turns in the coil. How the self-inductance of a coil depends on the number of turns in the coil. That is for 1 mark. 2 mark question. There is no 2 mark question. 2 mark question nahi dikh raha hai. 3 mark question. 3 mark question is also not there. 3 mark question is also not there. Then there must be a 5 mark question. There must be a 5 mark question. So 5 mark question. Yes, 5 mark question. It is 5 mark question. A numerical is given. 5 marks numerical is given, and this numerical also we have solved. And I will read the numerical. A conductor of length 3 meter. A conductor of length 3 meter moving in a uniform magnetic field of strength 100 Tesla. It covers a distance of 70 meter in 5 seconds. Its plane of motion makes an angle of 30 degree with direction of magnetic field. Calculate the EMF induced in it. We have already solved this question. So this is asked in April 2019. That is March 2019. Understood? Okay. Then last question paper, June 2019. June 2019. 1 mark question. Write any one advantage of eddy current. Write any one advantage of eddy current. 2 mark question. 2 mark question is not there. 3 marks question. 3 marks question is also not there. That means there must be a 5 marks question. 5 marks numerical or theory? See here. 5 marks theory question they asked, not numerical. Theory question. 5 marks theory question. 29. Question number 29. Derive an expression for instantaneous induced EMF in an AC generator. Derive an expression for instantaneous induced EMF in an AC generator. You have to derive that I is equal to I naught sin omega t. That is for AC theory of AC generator. Theory of AC generator. So that derivation carries 5 marks. So that is asked in this question paper. That is June 2019. Understood? Okay. So this is how the questions were asked in the previous theory exams, and some more question papers are missing. I don't have all the question papers, so 2-3 question papers are missing, and from that 2-3 question papers different type of questions are also asked, and you see to that and make your studies on this chapter related to theory. Understood? So this completes the electromagnetic induction. In the next class we will start with alternating current. In the next class we will deal with alternating current. Understood? Okay.